We are happy to announce our first English-speaking webinar during this ASQF Net Week. Welcome, Florian Kämmerer. My name is Anna-Christina Feldhusen. I'm from the ASQF, and I will guide you through this webinar. Today, the topic is integratively testing of a distributed microservice landscape. For the further webinar, please feel free to ask questions by using the chat or the question function. We will be happy to answer them after Mr. Kämmerer's webinar. Also, if you want to, you can also ask the questions in German. That's not a problem for us. So for now, the stage is yours, Mr. Kämmerer. Enjoy the presentation. Thanks.
Thanks a lot and welcome everyone, and thanks for joining me. Like introduced, I wanted to talk a little bit about integratively testing of a distributed microservice landscape. Rather the way we approach this topic and what experiences we had, what problems we faced, and how we overcame them during this period. But first off, a little bit about myself. As of today, I'm 33 years old. I joined the Deutsche Bahn in 2013, studied computer engineering, agile developer since 2015, and I have just a passion for quality assurance, automating stuff, breaking stuff mostly. Today we're going through the following topics, a little bit of context about the program we are working on, pipelines in general, then integration tests, pipelines again, modularization of test sets, and visualization of test reports. First off, a little context. Our program consists of about 300 people all in all. We are 16 more or less independent domains. Domains means something like this domain is has to handle the payment. The others take the materializing of the tickets and stuff. And these domains are organized in 6 clusters. All in all, we have about 200 different microservices. This is front end. This is the back end of the front end. That's the actual back end. This is databases, everything. We are completely running in EKS, Elastic Kubernetes Service by AWS. Every team has its own CI/CD pipeline, continuous integration, and continuous deployment from test stage till production. So per day, we have about 50 deployments every day, more or less. Sometimes it's about 20, sometimes about 60, depends on the working day of the week. Our microservices are written in diverse languages and frameworks. We have Java, we have C++, we have Node, Vue, TypeScript, and so on and so forth. First off, like I said, we're going to talk about pipelines. Every team is independent, and every team needs to be able to deploy and build their services. So every team started to create their own build pipelines, or they were told to create their own build pipelines. So naturally, what will they do? They will build the easiest thing they can find. So basically, we need a pipeline that builds our stuff, tests, a little bit of analyzation, and it deploys to an artifactory or something like that. So the build artifact is deployed somewhere, and we are done. We can go have a beer or something. Well, not that easy. When you are working in microservice landscape, you have to work with others. So our product may be properly unit tested. Our own little service is unit tested. It's analyzed, but we didn't test the running service. We just deployed it into an artifactory, put it the jar artifact or whatever, the exe, or even the Docker container there, and we are done. So we didn't really test our running service, and we didn't integrate with other services. This is basically the point where we all started off. Every team built their own little microservice, put it somewhere, and say, okay, we are done. So the first presentation of our product, or the first event where we try to show the product. We had a little trouble beforehand to get it running. So from that we need to test with everyone. So first off, our teams were asked, okay, test your running services within the cloud, within the EKS. So the teams extended their build pipelines, something like that. So the product is built, it's tested, it's analyzed, so that's like before. And then the service is put into Docker, is deployed to EKS, it's booted up, and some API tests are run against this service. Everything else was mocked if they needed dependencies. So now we have automated testing against the running service, but still we didn't integrate with others. So what we needed are integration tests. So the first approach, or still the way we are doing it today, is we have a centralized test project where the tests are developed. This test project has its own build pipeline, Jenkins file in this case, or in the beginning it was a Jenkins file. And every team had to integrate this test pipeline into their own. So basically they are running their build pipeline step to step. And after the deployed service, they started this integration test pipeline. These integration tests are calling the services, testing them, asserting the responses and so forth. And the tests are successful or they fail. The response is then given to the build pipeline and the product is tested. So the idea at this point. So what we achieved with that, we are integrated with others. But the problem we got with that is that the teams now need to maintain a pipeline for these integration tests. So the team build pipeline where they're building their service, testing their service, analyzing their service, that's their own code. They know this code, they developed it. But the centralized integration test pipeline, that's a centralized project. There are contributors from all over the program. So like I said in the beginning, we are about 300 people in the program. So there are a lot of people who can contribute to this. To analyze failing test pipelines, so you have to imagine you're running these tests in your Jenkins, and these tests talk to your service and to the service of other teams or other domains. So if the tests fail, it can be your own service that is causing the failure, but it also can be some other service. So you need to look into the test logs that are stored in your Jenkins at this point. You will see either your team is your service is the failing service or the service of somebody else. If it's somebody else, it's hard for your team to analyze these failures. So you need the help of the other teams to analyze this. So they need access to your build server. We have independent teams. They should only have access to their own build pipeline, to their own build services, and so on, and shouldn't need to look into the pipelines of others. That's one of the first bigger problems, one of the biggest problems we face at this point. And changing this test pipeline yields work for every team. Every team had this integration test pipeline integrated in their own build server, in their Jenkins server. And when we changed how the test works, if they need a new parameter or something in the Maven command or something like that changed, every team needed to change that in their build service. So we weren't really flexible with this. And what's additionally there, test pipelines, or adding another test pipeline, again, yields work for every team, because every team has to add this test pipeline. That's where we started from. To give you a little idea how these integration tests work, how they are built, we get taking a little excursus to the integration tests or journey tests. Journey tests in our program are basically a user journey through the system. So you have an integration test. That typically is a black box test. So it talks to the API of our backend. So we don't have a GUI at this point. It uses only the APIs that are accessible from for the front-end system. So no backtracking into a database or something like that. So we approach that to say, okay, our API is the only point of contact, is the only point of truth. So we want to use this for testing. Typical journey consists of multiple service calls. So for example, your first call will be, I want to go from position A to position B, or from town A to B. And then I want to pay for this. Next time I want my ticket, and so on. So if this is our system, we are talking about this part in particular. So no front-end tests, no GUI tests, just the backend at this point. Our tests are driven by Cucumber. Cucumber is a business, sorry, a little nervous here. It's a framework for business-driven development. The idea behind that is that business analysts can write tests or write their acceptance criteria into a test, which then can be easily implemented by the development teams. So we take some acceptance criteria from the business analysts and implement it. This is an example for a typical test that we are running within the journey tests. If you would print out the process, something like that, first call goes to the trip service, like saying, I want to go from Hamburg to Frankfurt somewhere in 3 weeks at 9 o'clock. This trip service will give us a number of responses or a number of offerings. We then pick one of these offerings and put it into a shopping cart service. The next step would be, I want to pay this. And in this case, we are paying with a credit card. And in the end, we want to have a ticket. So this is the user journey. This is the journey of the user through our system. Our first approach for communicating with the services, or general the approaches, these services have REST APIs. They are written typically in Swagger, or they have a Swagger definition rather. So we can use these definition to write clients. Our first iteration of testing these services was we were writing clients by hand. So we just took the functionality we needed or we wanted to test and just modeled the information we needed to talk to these services, to these interfaces. Like I said, we only implemented what we needed. But the problem is it's quickly outdated. Everything you do by hand is basically outdated the moment you commit it. The maintenance was really high because every change in an interface of a service, like I said, we have about 50 deployments per day. So 50 times per day there is something that can change in an interface, in a service, needs to be adapted. This process of manually writing this is error prone. Every typo, every wrongly named field will break the system basically. It's complex to the extent we needed to write new clients for every new service that we got, or every new service endpoint that was introduced at this point. So in our second iteration, we switched to semi-automatic generating of our clients. There we're using the Open API generator. That's an open source tool that generates clients, model classes, and everything you need to talk to a REST API. In our case, we are using this generator to generate clients written in Java and the models for the data that we receive from the API and that we need to feed the API to make this service work. This approach has one drawback. We have a lot of boilerplate code, a lot in emphasis. We are generating every client for every endpoint of the service. Even though we are maybe not using this client, it is generated. But that's the price we are willing to pay at this point. It's easily updated. Like I said, this generator generates the client and the model classes from the Swagger file of the service. So everything we need to do to update a client, to update a model, is to feed it the new interface. And we will end up with a new model class. At some points, the services will have breaking changes that will also break the tests, but this is basically the only point you have to manually update the test to make it work again with the service. Everything else is done by the generator. We have a quick feedback cycle, like you feed it the interface description, the Swagger file, it's generated. You will see immediately if there are breaking changes or not. Low maintenance, like I said, just the Swagger file and you're good to go basically. It's reusable. The generator is configured and can be used for basically for every new service that is introduced. Just feed the new interface file and you will end up with a client. It's an additional sanity check for the Swagger files. Most teams generate their Swagger file, their API interface description from their code. That's done by annotating the code and generating the model file, the Swagger file. But also some teams write these descriptions by hand. And everything you write by hand, there can be errors. And this generator provides the opportunity to check if the Swagger file is correct, if it's readable for a machine. So what we have now is basically a framework where we can easily introduce new services to if we need them to test, and we can easily add new tests that are written by our business analysts, or should be written rather by our business analysts. So when we are developing our system, we said everything needs to be tested. So every new feature has a story attached to it, and in this story, there's one point, write a journey test for it. So business analysts, like I said, writes the feature file, attaches this to the story. The developer then takes it, puts it into the journey test set, and implement missing steps if there are any. So process would be something like that. If you need a new service, just add the Swagger file to the test set, to the journey tests, and the client is generated. You maybe need to configure a little bit like the service URL, authentication, logging, and so on, but the basic client is out of the box working in most of the cases, to be honest. Then the new test file is added, the feature file, the Cucumber feature file, that represents the acceptance criteria of this feature of this story. The developers, with the knowledge how the concrete service that is supposed to be tested works, write the step definitions, how actually, how the communication with the service works at this time. And after this, the test is present in the journey test set. That again is run by every team within their build pipelines. Talking about pipelines, you saw where we left off. Every team has its team build pipeline and the integration test pipeline. The problems with that were maintaining the pipelines, the other teams need access to their build services, adapting the pipeline yields work, and so on and so forth. So to solve these problems, we try to get this test pipeline out of the build server of the teams. So we introduced an own separate pipeline, the quality gate pipeline, that is rather called by the team pipeline via a Docker container. So what this Docker container does, or how it's work, is that the team starts a script within their build pipeline that boots up a Docker container, which then again holds the quality gate pipeline, starts, polls for the status, and returns the status to the team build pipeline. So now we have a separation layer between our team pipelines and the test pipelines. The test pipelines doesn't need to be in the team build server anymore. We can use our own build server for that. The information that is needed for the quality gate pipeline is just passed by the teams, some minimal information like a trigger token, domain shortcut, and so on. The rest is encapsulated into the quality gate pipeline and is transparent for the team. So with that, we can centrally maintain this, this test pipeline. The test logs are now at a central place, so the team can access the build server, the central build server, and check the log if one of the tests failed. The test pipeline itself, so the journey test pipeline in this case, can now be changed without yielding work for the feature team, for the domain teams that earlier had to adapt the pipeline. But the problem is the teams still need to access the build server to see the logs. We'll get back to this point later on. With these quality gate pipeline, we now have the opportunity to add new test sets to our quality gate. So we started out with the journey tests, basically backend tests, backend integration tests. We now have the possibility to add multiple other test sets. In this case, this would be end-to-end tests for the web. In this case, GUI tests. This can be done without any of the teams noticing, without yielding work for any of the teams. This is transparent for the teams. So we can add and remove test sets centrally as we need them, or we don't need them anymore. So maybe we have some web tests, maybe we have some mobile tests, whatever tests you can imagine, we can add them to this quality gate without teams noticing. The problem is still test logs are in this central server, in this central test pipeline, and every test set is currently run for every team. So with more and more test sets added to the quality gate pipeline, the time that is needed to run these tests are ever increasing. And maybe there are tests that aren't really relevant for the team that is just that is running this quality gate pipeline. So what we needed now at this point is we needed the possibility to separate what tests are run for which team. So what we needed, modularization of the test sets. Modularization of the test set basically means just running the tests that are relevant for the triggering team. Going back to the feature file you saw earlier, Kämmerer has the possibility to add annotations, tags in this case, to the feature file. We use these tags to decide which tests are run for which team. So you see here tags like @rl, @bue, start, tck, and so on. We use them to decide which tests are run. So for example, the team RL, German Reiselösung, starts the quality gate pipeline. We will split up the journey tests into 4 different sets. The first set is every test that has the tag mandatory. These tests, there's a typo, these tests have to be run every time. Every team needs to run those tests. Every backend team, I should say at this point, needs to run these tests. The second test set are all tests that have the RL tag. So these tests test something or some service that belongs to this domain. Third test set is every test that doesn't test a service of this domain. So Reiselösung, that's, for example, a service that provides the connection from one town to another. If your journey needs to go through this service, it will will have this tag. In development, the tests that are still in development, we add them to see what's the progress for the current feature that is developed at this point. For example, when web starts the tests, only the web front-end tests are run. That's just because when web deploys something new, we assume it can't break the backend of our system. If they have an error in their code, only their front end is broken at this point. So it doesn't need to check the back end while the test run for web. TCK is again a backend domain. So again, the same test sets are run like for RL, but the content of the test set may be different because not every test that has a TCK tag may have an RL tag. So what we achieve with that, only the tests that are relevant for the current team that triggered the quality gate pipeline are actually run. So we reduced the amount of time needed to run these tests, and we also reduced the number of tests that are run at this point. But still, to analyze these tests, we have to access this the build pipeline, the build server. So we needed a possibility to visualize our status of the tests without accessing this build pipeline. So we introduced a little tool called Window Dash. Basically what it does, it's a service that is triggered by the quality gate pipeline. The quality gate pipeline says, hey, I just started to run and I will be running these test sets. The quality gate pipeline then starts the test sets, and each test set reports its result to Window Dash. So the journey test report the status and the whole test report. You know, when you are running a unit test or cucumber test, you will have XML file or JSON that describes which tests were successful, which weren't successful, which failed, and with what error message. These reports are sent to Vendor Dash. Same for the front-end test from web, mobile, and so on. In the end, the quality pipeline says, I'm done, all good, or maybe not, maybe they are failed tests. Vendor Dash then takes these reports and generates a human readable interface at this point. So beside the human readable overlay, the GUI, also the test report is generated by Vendor Dash. This is basically our tool, what you see here. We use that to monitor the state of the different stages in our system. We have a testing system, we have integration, we have Abnahme, presentation, and so forth. Other multitude of different stages. Each stage can be accessed with Vendor Dash. You have the result of the quality gate pipeline. I'm losing it, sorry. all the results of the quality gate pipeline are displayed here and broken down into the single test pipelines that were run during this quality gate pipeline run. And from this, you can access the generated report. So what we have now, summing up, we have the possibility to run multiple tests for every deployment we do within our program. So every team that deploys something or wants to deploy something in production automatically runs a multitude of backend tests or front-end tests and whatever tests there may be. The results are collected at the central point and can be viewed and analyzed by all the teams. We can extend these test sets without yielding work by the teams. Yeah, I think I'm running out of time here, but I'm basically done at this point. I would like to have shown you the actual Vendor Dash in reality, but I can't access the network from home at the moment. So we will have to do with the picture at this point. So that's it. Thanks a lot. Thanks for listening. Any questions at this point?
Yes, thank you, Mr. Kämmerer. Yeah, and indeed, we do have already some questions. So first of one is, sorry, didn't get it. What again is Vendor Dash?
Vendor Dash, it's a tool to visualize the result of tests. So every domain runs deployment pipeline, CI/CD pipeline, and within this pipeline, they trigger a quality gate pipeline that is centrally managed. And this quality gate pipeline itself runs some test pipelines. And the reports of these test pipelines are then sent to the Vendor Dash service, which then generates a report that is human readable. So Vendor Dash, just the name of our tool that we wrote specifically for this use case to visualize the results of the tests.
Okay, thank you. So another question. Do you have versioning? How do you identify a running version if you deploy 50 times a day? If you want, you can also look up the questions in the Fragenreiter if you need to see them written down.
Yeah, I just saw. Yeah, I see another question. Behavior driven. Yeah, that's right. Sorry for I misspoke at this point. Versioning. Versioning is managed by the domains itself. That's not the focus of this tool. I think we are running up to 3 different versions per service within our program to enable testing for these versions. You just would have to add a Swagger file for each of the different versions to the tests, to the journey tests, and you will end up with 3 different clients that can talk to the different versions of the service. So we can be backwards compatible with the tests or support older versions of the service as long as they are still running. As soon as they are shut down, the interface is removed from the tests and the client and the code is deleted.
Okay, thanks. So another question, can the client generation be compared to automated mock generation based on the contract /Swagger doc?
Not sure about the question. If you're talking about consumer-driven contracts at this point, I think the code generation that's provided by the OpenAPI code generator goes further. It's not just checking a stub or mocking a service. It's a client for the actual running service. The client can be based on different HTTP client libraries like Jersey or something like that. I'm not sure about the question, to be honest.
Okay.
Können auch gerne Fragen dann auch in Deutsch beantworten.
Ach so, okay. Okay, kein Problem. Gut, die Fragen sind jetzt auch auf Englisch gestellt. Also, wie behandeln Sie denn Testdaten künstlich oder DB-Extract? Ist hier noch eine Frage.
We don't actually use that much of test data. If you're going back to the test I showed you, the test actually requests a connection between Hamburg Altona, I think, and Frankfurt am Main. So there is no store test data. The connection is calculated at the moment in time we request them. So we don't need to store test data at this point. We are running the tests against the actually running services. So even if we need a customer or a user account, we will create, can't talk anymore, create this account on the fly during the test and delete the account after the test.
Okay. So one more question regarding the content. When is it possible to run tests? Only before deployment or also for a system already in operation?
The test can be started at every point in time. What we provide with the quality gate pipeline is an integrated test mechanism for the deployment pipelines. You always can go into the repository. It's accessible for all our developers and manually start the tests. In most cases, you just need to set some environment variables. For example, what team is testing at that point, or against which stage the test should be executed. So it can be run at any point in time.
Okay, thanks. Eine Frage jetzt noch auf Deutsch. Wäre es möglich, dass Sie die Folien zur Verfügung stellen im Anschluss an die Teilnehmer?
Müsste ich nochmal in Rücksprache gehen, ob ich die so veröffentlichen darf, aber wegen mir gerne.
Okay, dann werden wir uns bei Ihnen nochmal melden bei den Teilnehmern. Und noch eine Anmerkung. Very interesting and valuable journey. Thanks for sharing. That is also what I can just say. And also one short brief note, you can get a membership at our association with a 50% discount during this Net Week if you want to, if you aren't a member of the ASQF yet. Yeah, the recording will be available pretty soon, I think, of this webinar. So I just have to say, have a nice day, and thanks again, Mr. Kämmerer, for your speech.
Thank you.
Okay, bye.
Bye.